Hi, good morning, everyone. Today we're going to continue with word problem. Let's take a look at number one. A water tank at Camp Newton holds 1,200 gallons of water at t equals to 0. During the time interval t is between 0 and 18 inclusive, water is pumped into the tank at the rate Wt. This is Wt. During the same time interval, water is removed from the tank at the rate of RT. So we get the in and out. The question part A, is the amount of water in the tank increasing at t equal to 15? Why and why not? So we had the rate in, that is Wt. We had the rate out, that is RT. And then we got the initial amount, 1,200. So part A, they ask you to find, is the amount of water in the tank increasing at t equal 15 or not? So basically means, is the P increasing or decreasing at t equal to 15? So where the P of x or P of t is the amount of water in tank. So very similar to what we did yesterday. So now we are going to use P prime at the 15. So we're going to find the sign of the P prime. If the P prime is positive, then the answer is yes. So now let's take a look at P prime. So yesterday we talked about it. If you have an integral the integral of the rate in minus the integral rate out plus initial amount. So we say that P prime basically is going to be the rate in subtract the rate out. So P prime will be Wt minus R of t. Then P prime of 15 will be W of 15 minus R of 15. So we just have to find the value of this. So today we're going to use calculator to solve this problem. So we're going to go to a calculator, make sure it's in radian mode. So you get 95 square root t sine square. But when you type in, you cannot insert a square over here. So you have to put the whole thing to square. So you should 95 square root of x, and then open parentheses sine x divided by 6 close, enclose the whole thing square. Now we're going to the RT, 275. And then same thing for the square, you could open parentheses, sine x divided by 3, close and close, and then holding square. So now we want to find the P prime 15, which is the W15 minus R15. So I already had y1, y2. So today I'm going to show you another way to do it. So I'm going to make my y3, that is y1 minus y2. So my y1 is Wt, my y2 is R of t. Then my y3 equal to y1 minus y2. So basically my y3 is Wt minus R of t. So once I get this, all I need to do is going to be y3 of 15. So that means it's y3 of 15 equal to W of 15 minus R 15. That's what's going to be behind the scene. So now I am going to second mode, go back to main screen, and then I'm going to do VAS, YVAS function, and then pick 3. I got y3 and 15. So now I got negative 121.090. So P of 15 equal to negative 121.090. So the sign is negative. They ask you, is this going to be increasing? So no. Okay, P prime of 15 equal to negative 121.090. Negative. So the water in tank is not increasing at t equal to 15. So we finished part A. Now let's take a look at part B. Part B, to the nearest whole number. How many gallons of water in tank at the t equal to 18? Okay, so this one is gonna look like what we did yesterday. So B, we're gonna be find P of 18. So integral of the rate in 0 to 18 Wt dt minus 0 to 18 the rate out dt and plus 1,200. We're going to type this into our calculator. So we're going to do math 9, 0 to 18. Okay, y1 will be our first one. Subtract math 9, 0 to 18, and then function y2 dx and plus 1,200. So it had to be in radian mode. So now we got 1309.788. And in the beginning it says to the nearest whole number, so we're going to round it to, so this round up, so we get 1310. So we got 1,310 gallons at P of 18. Let's take a look at part C. Part C, at what time t is between 0 to 18 is the amount of water in the tank is an absolute minimum. Show the work that leads to your conclusion. So now part C. The key will be when water is absolute mean. So that means P of t is absolute mean. So we have to use P prime of t equal to 0. We're going to find the critical values and see where you're going to get the relative mean. If there's one, there was more than one, and then you're going to compare. If there's only one, then that will be the only one. So now we got P prime of t equal to rate in minus the rate out. So P prime of t equal to Wt minus Rt. So we're going to make P prime t equal 0. In other words, we're going to make the Wt minus Rt equal to 0. Let's take a look at these two equations. They're very complicated. We definitely do not want to solve by hand. So how do we solve it? So we get y3 equal to Wt minus Rt that we did in the beginning. So we just had to graph the y3 and find the zeros. So now we're going to graph it. So before we graph it, all we had to change our window into the one that we want, which is 0 to 18 in this case, 0 to 18. And then I had negative 100 to 100. I can make it negative 10 to 10. Okay. And then we make sure we only graph the. So here I had three functions, so I had to unhighlight one and unhighlight two. Just let the y3's highlights on that graph. Okay. So if this is not clear, it looks like it's going to be much bigger. So let's change the window. So I'm going to change the window a little bit. So make it negative 200 and 200. So I have a better picture. You can also do the zoom. Okay. So now over here, I can see it that is not touching the 18. Okay, so you're going to have to sketch it. So you're going to be from the 0, go back up, go back down. So now we had three numbers, so 0, and you got T1 and T2. So this one you get from negative to positive, so you're going to get a relative mean. This one is a relative max, I don't care. The reason is because we have to find the absolute mean. So now we're going to sketch a little bit with the side chart. you get 0, T1, T2, and 18. So we're going to find out what T1 is. Second trace, 2. It's 6.4948. So that would be 6.4948. So I finished finding my T1. I don't need to find T2. So I got negative, positive, and negative, negative, positive, negative. So I'm going to go from here to P of T1, and then you got P of T2, and then I got P of 18, and then P of 0. So based on this, we know that we'll have two relative mean. P of T1, which is P of 6.4948, and P of 18. So let's see which one's bigger. P of 18, we already found it in part B, which is 1,310 gallons. So all I need to do is find P of 6.4948. So let's go back over here. I already have this in the calculator. I'm going to type second, enter. So we call the memory. I'm going to delete the number. So I got 6.4948. Go to the other one. 6.4948. Now I'm going to put enter. I got 525.242. So now definitely this one's smaller. So we got absolute mean at the 6.49428. So the amount of water is absolute mean at T equal to 6.4948. So we finished question part C. Let's take a look at part D. Part D. For T is greater than 18, no water is pumped into the tank, but water continued to be removed at the rate RT until the tank become empty. So that means nothing inside. Let K be the time at which the tank become empty. Write but do not solve. An equation integral involving integral expression. Write but do not solve an equation involving an integral expression that can be used to find the value of K. So part D. So we are at T equal to 18. We get 1,310 gallons of water. And then no water going in. Only water goes out. And then it keeps going until a time K, then it's empty. So that means we begin with 1,310 and we're going to subtract the amount that go out and equals 0. That will be empty. That will be the idea behind it. So to find the amount go out, we use integral. So we get 1310, subtract. So we had to use RT because that's the rate out. So what time should we use? No water goes in at T equals 18. So therefore, that is the time that the water goes out only. And then they want us to use a K, and this is the time that we do not know, so we put K. So this is going to be the equation, an equation involving an integral. And we don't need to solve it. So we finished part D, and we finished question number 1.